Yes, hi guys. And today I have to talk about substitution in case of definite integrals. Okay, how to substitute in case of definite integral. Definite integrals means when limits are given. Okay, in the simple way, what we have to discuss here that first of all, just like indefinite integrals. Okay, we have to first integrate the given integral or given function. Okay, then after finding out the integral, okay, of that indefinite integral, just like indefinite integral, now we have to put the limits. But if we have, in case of making the integral integrable, okay, that whatever integrand is given to us, that is to be made into integrable, then what we have to convert, we have to substitute something, the original variable, suppose x, to another variable t, and after converting this into variable t, and the function is integrable, and this is advisable that we have to change the limit also. Okay. For the first, the previous limits were given in variable x or for variable x. Now this variable x limits are to be converted into variable t's limits. Okay. So for example, when x equal to a and b are the limits, lower limit and upper limits. And suppose x equal to a, then what is value of t? And when x equal to b, then what is value of t? In this way, we will okay, calculate it. So that in this case, the okay, the convenient thing will be that we have not to return to the same variable again. But in this case, it is very uncomfortable sometimes or very troublesome that we have to return to the same variable. Sometimes we are just forget. Okay, we forget about converting to the same variable, so same original variable, because we have answered the question into, or the integral is in terms of t, the change variable. But sometimes we forget that we have to return to the same variable, and we substitute the limits of the x variable into the limits of t variable. That is a bit difficult time, okay, and bit very difficult task. Just to remove that kind of inconvenience, what we do, we have to change the limits also, the changed variable t. Okay, after that, there is no need of returning to the same variable x or original variable x. In this case, this will be advisable for this. I'll just explain this whole thing. And after substituting these, okay, and the same thing as we were substituting in case of indefinite integrals, in case of definite integral also we have to substitute the same thing. We have to find out the integral of the given function after converting it into the new changed variable. Now the function is integrable. So after integration, now we have to substitute the limits. Okay, and the final solution will be obtained. So in this way, the process is the same. Now let me explain the process one by one. Okay, so first definition is that substitution in case of definite integrals. This is the topic of the definite integrals. Okay, so what is the process here? As I've just told you, that this is the first process. First integrate. I'm talking about the working group. First integrate the given integrand. Okay, after substituting the original variable, or substituting the original variable for the new variable, substituting the original variable for the new variable, so that the function becomes integrable, so that the integrand, or the function which is to be integrated, becomes integrable. Okay, so this is the first thing. Secondly, what we will do after the substitution, okay, for the original variable, for the original variable, for the original variable, say for x, the new variable, t is substituted, and to avoid the inconvenience, inconvenience, the limits are also changed. The limits are also changed. The limits are also changed to the new variable. To the new variable. The new variable, so that going back to the old variable, that means original variable, is avoided. Okay, this is how limits are to be changed. Now integrating, after integration, the limits are substituted. The limits are substituted in the terms of new variable, in the terms of new variable, or in the new variable, in the terms of new variable. What does it mean? So that we have not to return now to the original variable, of new variable, in the terms of new variable t, which is t here. We have taken t here. Okay, so let us take, let the function sign of integration, let me take f. There is f is a function of gx here into g dash x dx. Okay, let us and the limits are, let us take a to b. Let us assume or substitute gx equal to t. Therefore, differentiating it with g dash x into dx upon dt equal to 1. Integrate and differentiate with respect to t here. That means g dash into x dx equal to dt. Substituting this here, it will be converted into, or limits are what are just convert the limits also. This will be when x is a, then gx equal to t. Okay, so t limits for a will be here ga. Okay, here the limits will be ga, and the limits are, and the new limits are, this is ga for lower limit and gb respectively. How we have substituted x, okay, a for x, b for x. Therefore, in this function, what is the value of t? For that, in the terms of new variable, it will be ga and gb. The limits are ga and gb. Okay, so this is ft into dt. Let us take this function comes out to be ft. Integration of this is ft. So it will be ga and gb. final answer will be what? FGB minus FGA. Okay, this is the answer here. This is the answer in this case. So limits in terms of GB and GA, we have to substitute in terms of t variable. This is just ft. Suppose the integration of this function ft dt is ft integration, and after that we will substitute the values of the limits GA and GB. The final answer will be this GA and GB. Okay, and if we are not converted, let me take, if we are not converted in the same equation, we have to substitute this function. So the answer will be then FGB. Okay, and if we are not substituted, now let me check whether the answer is same as the original variable, and we have not converted the original variable x into t, or we are not substituted, and then what will be the answer? If the original variable, original variable is not changed, then this is sign of integration a to b. This is f g a, sorry, gx g dash x dx. Let this is equal to integration in fx. Then what is the limit? Sorry, fgx. I'm sorry. Here it is function is of gx. Capital Fgx is the integration of this whole function. Okay, so then limits are a to b. Final answer will be, substitute the values of this one. It will be gb minus fga. The same thing we have obtained here. This result and this after substitution in terms of p, the answer is obtained same. And in the case of without substitution, we have got the same answer. With this integration was this one. This is g dash x given to us. Okay, so after integration, this is equal to g fgx. Okay, so same answer. This is and this answer same. So this is equation. Let me take one, and this is the second equation. So from equation first and second, integration of this without let me take f. This is gx g dash x dx equal to the same thing here. This is sign of integration ga gb ft dt. Same thing, same answer is coming out, which is nothing but f gb minus f gb, sorry, ga, lower limit is the answer. Both these are having the same answer. So this is how we have not reached up to the original limits. Just we have found out the change the limits as well, and after just integration of the function in terms of t variable, we have substituted the limits. The answer is the same as without substitution. As the answer was in terms of x here, the same answer is obtained. So in this way, this is what is the use of substitution. Okay, and the limits are also changed. Okay, so limits are also converted to the new variable, so that we have not to return to the same original variable, old variable x, so that we can avoid the what do you call the troublesome which mostly we suffer. Let me take the questions now. These questions will clarify that how we substitute in case of definite integrals. Definite integral is a part of integral, so we have to take this topic for every method. For example, in this case, substitution method, we will talk about the by parts method. In by parts method also we will discuss about definite integral, how to solve definite integrals in case of by parts method. Okay. Then in case of partial fraction also we will talk about partial fraction for indefinite integral. Then for definite integral finally we'll talk about. So in this way we are processing, taking all the methods, how they are used for indefinite integral as well as for definite integral. In this case now this is the last topic, last lecture for substitution method. In this case substitution method are just finished today, so that we can have the complete information regarding substitution method for indefinite integral as well as for definite integrals. Now let me take the questions. Now question number 1, what does it say? Now it says sign of integration, it is limits 2 to 3. It is twice x upon 1 plus x square into dx. Now in this case, let us again substitute. What is substitution method here? That denominator 1 plus x square equal to d. Okay, so differentiating it with respect to d. With respect to d, we get, what do we get? This is twice x, this one, into dx upon dt, because x is not t. So differentiation of x will be dx upon dt. And we are differentiating with respect to t, so this is 1 twice x dx equal to dt, or x dx equal to dt upon 2. This is value of x dx, okay, or twice x dx is there given to us. So this is dt directly, okay, no need of writing this. This is the same value, twice x dx equal to dt. That we will substitute. Now come to the limits also. Now changing the limits. Let me write here, changing the limits also. Changing the limits also. When x equal to here 2, let me take the lower one. When x equal to 2, then t equal to 1 plus 2 square, but in place of x we have to substitute 2 here. It will be 1 plus 4, that means 5. Lower limit is 5, and when x equal to 3, then t is equal to again 1 plus x square, means 3 square, that means 10. 9 plus 1, 10. So limits are finally 5 to 10. Therefore, substituting these values, okay. Therefore, let me write here. Therefore, substituting those values here. So therefore, this is equal to, let me write directly. The limits are 5 to 10. We have converted it into t, that means dt upon t only. Okay, this is dt totally 2x, sorry, twice x dx in the numerator divided by t, because this we assumed as t. So its integration will be log of t. Okay, now limits are here 5 to 10. Now substituting the limits in place of t here, because there is no change of need of changing the t variable into x, because we have converted the limits also. Okay, now I'll just solve it, because after substitution we can get what the answer here. So this is final answer, log of, first we put the upper limit, that means 10 minus log of 5 lower limit, and we can write it as log of 10 by 5, log n minus log n, log 10 by 5, that means log of 2, 5 to the 10. Log of 2 is the answer here. Okay, so final answer is log 2. So this is what we have calculated. So this is the answer. In case of definite integral, no constant, but constant of integration in case of definite integral is removed. The value finally is log of 2 to the base e. Let me write here the base e. So base is not given mostly, but when base is not given, that means this is natural base e for finding out log of. Okay, log of any question. So this is first question we have done. Now let me talk about second question and substitution in that case also. Now question number second, let us talk about with the question number second. Question number second here. So what is the question number second? This is sign of integration, limits 1 to 3, cos of log of x divided by x dx. Let us take or substitute log x equal to, let log x equal to t. Differentiating with respect to t, we get, it is 1 upon x dx upon dt. Why? Because x is not t. Differentiating x with respect to t dx upon dt. Again, because when y is differentiated in case of when x is independent variable and y is dependent variable, then this differentiation of y is dy dx. Similarly, in this case, x is the dependent variable on t. We are differentiating with respect to t here, which will be 1. Therefore, 1 on x dx equal to dt. This dx upon x is equal to dt. We will, or let me change the limits also. Okay, and limits, let me write here just limits. When x equal to 1, x is 1, then t is equal to, this implies that t equal to, from this log 1 is 0, because log of 1 is always 0. Then in 3, when x is 3, and when x is 3, then t equal to log 3. This is log 3. Because we have to substitute here in place of x only the value of the limits, which is t equal to log 3. Okay, log 3. Then substitute here. This is 0 to log 3. This is equal to, therefore, limits we have converted. This is cos of t into dt. Okay, this is what we have obtained, the function which is now integrable. Integrating this now, we get here cos t is sin t positive. Limits are 0 to log of 3. This is nothing but, sorry, sine of, substituting the limits here in place of t is sine of log of 3 minus sine 0, which is 0. The final answer is sine of log of 3. This is the answer. This is 0. This is equal to 0. So only this value is left over, sine of log of 3. This is the answer. Okay, so in place of t we have to substitute log 3. Nothing else. This is the answer here. Question number 2 we have done. Sorry. Now let's talk about question number 3. Okay, question number 3 is sine of integration, it is 0 to pi by 4. Here cos of 3x dx. Now in this case, for 3x is there, otherwise we know that whenever x is multiplied by any coefficient, after integration we divide that integral by the coefficient of x. Directly we can do this integration, but let us substitute, let 3x equal to t here. Therefore, differentiating with respect to t, we are differentiating with respect to t, we get, let me write here, it is 3 into dx upon dt. Okay, this is equal to 1 or 3 dx equal to, sorry, this is dt equal to dt. Substituting value here, that means dx equal to dt upon 3. This is this value. Now limits are changed. Okay, so let's talk about limits here. When x equal to 0, then t equal to 0, because 3 into 0 is 0. And when changing the limits here, when x equal to pi by 4, then t is equal to 3 into pi by 4, or 3 into x means pi by 4, 3 pi by 4. This is the answer, and limits are there. So therefore this question will convert into 0 to 3 pi by 4 into cos of t into dt by 3. This is 1.3 we have taken. Cos t is again sin t. Limits are 0 to 3 pi by 4. Okay. This is equal to how much? Sine of 3 pi by 4. 1.3 here. This is sine of 3 pi by 4. 3 pi by 4 means 135 degree. 45, 45 to the 90 and 135 degree. So 135 degree will be how much for the value of this sign is positive in case of second quarter. The value will be positive, the same value 1 upon root 3. Okay. Why? Because sin 45 degree, the same value will be of this. It is sin 45 degree. Or we can write it as 180 degree minus 45 degree, that is 135 degree. Okay, so we can, if we are not able to understand, let me talk about this. This is nothing but pi minus pi by 4. This is 3 pi by 4. The same thing, we can write it now. Sin pi minus theta is sin theta, that is sin pi by 4. Nothing else. So this is 1.3. Sin pi by 4 is 1.2. Sin 45 degree. 1 root 2 at the cost 45 degree. The same value 1 root 2. The answer is 1.3 root 2. This is the answer here. Because sin 0 is 0. For this, after substituting lower limit in place of 0, I mean t, so sin 0 is 0 minus sin. That is the negative value, sorry, minus 0. Only this value will be positive. I have not substituted lower limit, but that will be 0 here. Okay, so let me write here. This is 1.3 sin 3 pi by 4 minus sin 0. This is equal to this much. Sin 0 is 0. This value is 1.3 root 2. This is the final answer. Okay. Question number 3 we have done. Let's talk about question number 4th. Put the question number 4th here. Let us talk about question number 4th. Question number 4th is, okay, what the question number 4th, sign of integration is 0 to 1 limits twice x upon 1 plus x4 dx can be written as 0 to 1 twice x upon 1 plus x square whole square into dx. Again substituting, let us talk about, let us take x square equal to t, this x square. Then it will be differentiating, let me direct do it, twice x into dx equal to dt. Same value. Now, because it is twice x first, then x is again differentiated, dx upon dt is equal to 1. Take dt to that side, now limits. Now let's changing the limits. When x equal to b, always substitute here lower limit first. When x equal to 0, t equal to 0, well, in place of x we substitute here 0. Let me write here 0 whole square equal 0. Or in place of x we have to substitute 0. And when x equal to second upper limits, when x equal to 1, then t equal to, when t equal to 1 square, that means 1 only. So limits are 0 to 1 again, no change. Okay, so no change here, limits are same, 0 to 1. So limits are 0 to 1. This is converted to this twice x dx equal to dt. This is dt upon 1 plus t square, nothing else. Okay, so it is nothing but tan inverse. We know that this is tan inverse 0 to 1 limits. We have converted the limits also in the terms of t. So now finally we have to substitute the values. This is tan inverse 1 minus tan inverse 0. Tan inverse 1 is for pi by 4. This is pi by 4 angle minus 0, 0 angle for 0. So tan inverse 1 is for pi by 4. Tan pi by 4 means sin pi by 4 upon cos pi by 4. That is pi by 4 here. So that is 1 here. Okay. Tan theta is equal to, so theta equal to pi. So only pi by 4 is the answer. This is the answer here. Simple. Okay, so this is question number 4th. We have done here. Now let's talk about question number 5th. So this is what definite integral. We have to first find the integral, just like indefinite integrals. Just substitution of the limits is added here. That is definitely zero. But here value is, there is no constant of integration. Constant of integration is removed, so value is unique. It's definite integer known as definite. The value is not changed. So this fifth question let me take now. Now this is 5. Here limits are not given. Okay, now I'll substitute the limits here. Same limits, okay, no problem. I'll take the limits here. So let me take 0 to pi by 4 limits. 0 to pi by 2. Okay. Let me take 0 to pi by 2 limits here. Because the limits are not given. 0 to pi by 2. Let me take. Here let's further convert it into, this is under root 1 minus, let me take this as x, this is x, sorry, 5x cube, it is 4 whole square into dx, this is dx. So x4 whole square means x8, no change. Now let's suppose x4 equal to 3. Let x4 equal to t. It means we have to not take the limits from 0 to pi by 2 because it's still it is in x terms. Let me take 1 here, 0 to 1 limit. Here also let me take 1. But still it is in terms of x. If it is all sine inverse, then we take pi by 2. Okay, so here it is 0 to 1 limits. Now let's just substitute. Let x4 equal to t. Therefore, differentiating it with respect to t. With respect to t, we get. So this is 4x cube dx upon dt equal to 1, or 4x cube dx equal to dt, or x cube. Sorry, x cube. I'm sorry. Change. This is x cube dx equal to dt upon 4. Now let me talk about limits. When, let me write here limits. Limits. When x equal to 0, the lower limit, then t equal to 0 or 0 4, 0 4, t equal to x raised power 4, that means 0 power 4 equal to 0. This is 0 here. And when x equal to 1, then t is also 1 because this